Welcome back, Geometry Scholars. Today's lesson is on triangle congruence criteria. Our essential question is, how does algebraic knowledge of lines help to solve problems about geometric concepts? And today's objective is that you will be able to determine if two triangles are congruent and explain why. Our first example says, find the value of the variable that results in congruent triangles. So looking at example A, we have triangle JKL and triangle MNP. And we are looking for the variable that would result in these congruent triangles. So we need to find what x equals. So we know we have 5x plus 30, and we have to set it up to equal something. If we want to solve for x, we have to have an equal sign. Because both triangles already have a 55-degree angle and a 45-degree angle, I can easily find what's left. How many degrees are in how many degrees are in a triangle? 180. How many do I already have? 55 plus 45 is 100, so subtract 100 from that. We have 80 degrees left. So both triangles have 80 degrees left. So 5x plus 30 equals 80 degrees. And I'm solving for the variable. Subtract 30 from both sides. 5x equals 50. Divide by 5 on both sides. X equals 10. So when x equals 10, that variable value results in congruent triangles. And that used some algebraic knowledge that hopefully you have carried over from Algebra 1. Let's go down and do letter B together. I noticed that triangle ABC has a 36 millimeter side, a 30 millimeter side, and a 50 millimeter side. And triangle DEF has a 50 and 30 millimeter sides also. So, in order for these triangles to be congruent, that 2y plus 20 has to equal 36. That's the only way those two sides are congruent. Subtract 20 from both sides. 2y equals 16. Divide by 2. Y equals 8. So in order for those two triangles to be congruent, y has to be equal to 8. Now we're going to look at three types of triangle congruence, and these are all types that we've done at Bell Work already, so this should be pretty comfortable and familiar to you. The first one is angle side angle triangle congruence. So if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Think about ASA. ASA is angle, side, angle. It's two angles, and inside of it, or included, or in between, is the side. So we have angle A is congruent to angle D. Angle C is congruent to angle F. And then the included side, or the side in the middle, AC, is equal to DF. So because we only know those three pieces of information, it's enough to tell us that the whole triangle is congruent. That means that B would be congruent to angle B would be congruent to angle E, and so forth. Okay? So that's the angle side angle triangle congruence. And all of these three that we'll be talking about today are theorems. Sometimes we use the word postulate, sometimes we use the word theorems. These three pieces are theorems. They're things that we have to prove. Okay? The next one is the side angle side congruence. And side angle side congruence says, if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So side, 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 angle, angle. I have the two sides and I have the angle in the middle. That's side angle side congruence. And that angle must be in between the two sides. The last one is side, side, side triangle congruence. Let's use some logic. What do you think is going to go on these lines? It's definitely going to be about sides. Well, how many of the sides? Well, side, side, side. That's 3. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. And I have a side, 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 and side, side. Those 3 triangles are congruent to each other using the side, side, side triangle congruence theorem. Example 2, let's determine whether the triangles are congruent, and we need to explain our reasoning. So looking first at example A, I see that they both have a 20 centimeter length side and a 19 centimeter. So 20 and 19. So it's looking promising. I see 2 sides. So now I need to check for the included angle. Well, the included angle is 43 degrees on the first triangle and 45 degrees on the second triangle. Are those congruent? Are those the same? No, they're not the same, so no, these are not congruent. And we don't have enough information from anything else to determine if maybe there's other sides. I mean, I know that we have a 15 here, but we don't have a 15 on the other one. So there's not enough information to see, well, maybe they're congruent another way. So no, these angles, no, these triangles are not congruent because the sides and angles are not congruent. And that's just using a little bit of logic to explain that. No, they're not congruent because the sides, I should say, and angles are not congruent. Okay. Let's look at example B. With example B, I have a side on both that is 2.3 centimeters. And I have an angle in both at 61 degrees. But in the first triangle, I have a 45 degree angle. And in the second triangle, I have a 64 degree angle. Well, since I have 2 angles, in example 1, I have 2 angles with the included side, I really need to figure out if I can figure out that missing angle. And can I do that? Can I find a missing angle if I already have 2? Yes, we can. We know that in a triangle, all the angles add up to 180. So 74 degrees plus 61 is 135. And when I subtract that from 180, you get 45 degrees. So now we know that we have another congruent angle. So with an angle, side, angle, we can prove this. Yes, according to the angle, side, angle theorem. So yes, these are congruent according to the angle, side, angle, and then tack on the word theorem. Okay? 3 things we're looking at. Are they congruent using angle, side, angle? Are they congruent using side, angle, side? Or are they congruent using side, side, side? And we may have some that are not congruent at all. Okay, example 3, our last section. Can the triangles be proven congruent with the information given in the diagram? If so, state the postulate or theorem you would use. So yes or no, and state how you know. I'll do the first 2 with you, and then I'm going to have you do the last 6 on your own. So looking here, I see side, side, so I either need an angle or I need another side. Since it has to be an included angle, it would be this one. Can I prove those angles congruent? No, I cannot. Can I prove any sides congruent? Well, the only other leftover side is this one. Can I prove it congruent? Yes, they're sharing the side, so obviously it's congruent. So the answer for this one would be yes, side, side, side theorem. Okay? Example B, I have an angle and I have another angle. So what we need is a side. Can I prove this using the included side? Well, the included side would be this one. And we know that if it shares a side, it's congruent to each other. It's the reflexive property. So yes, we can prove this one congruent using the angle, side, angle theorem. Okay, I want you to pause the video and attempt to do C through H on your own. Okay, you're only proving it 3 ways: side, 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 angle, or side, angle, side. Do your best, and then we'll check it at the end. Okay, guys, go ahead and check your answers. We'll go over them together. Letter C is no, because on the left triangle, although we have a side angle side, on the right triangle, the included angle is not included. It would need to be at this angle. This angle would need to be congruent in order to be side angle side, and it's not. So letter C is no. Letter D is also no. All we have is two sides. We have no way of determining if this angle is congruent to that angle or if this side is congruent to that side. So the answer for letter D is no as well. Letter E is yes. We have an angle. We have the included side because they're sharing it. We have an angle. So angle, side, angle. Letter F is also yes. We have a side, an angle, and a side. Side, angle, and a side. So yes, according to the SAS theorem. Number 8 is no, and I'm interested to see how many of you actually take a yes because of side, side, side. But all we have here are the fact that angles are congruent to each other. And we cannot prove that triangles are congruent simply by their angles. So the answer is no. And the last one, letter H, probably the most difficult one. Yes, you could easily see that they have a congruent angle. And hopefully you've noticed a pattern that they also have a congruent side. So we need another angle. But what I do notice from these marks right here is that those are parallel lines. And this is a transversal. We've been talking about transversal. So when a transversal cuts parallel lines, lots of different types of angles are formed. We already know that this pair is congruent because it told us already. But we also can say that these two pairs are congruent. Sorry, this pair is also congruent. And what kind of angles are these? Think about these parallel lines running on forever and ever and ever. They're inside. They are alternate interior angles. So now I have angle, side, angle. And so yes, this is congruent according to the angle, side, angle theorem. Okay, guys, just make sure you please write your summary. If you have any questions, write it here, and we will review this again next class. Have a great day.